Welcome, my coding friends, back to class number 3 in this 12-part series on learning Dart. In this class, we cover operators, conditional expressions, getting input from a user, assert statements, data privacy, and flow control. So let's jump right in. In computer programming, operators are symbols or constructs that tell the compiler to perform specific mathematical or logical manipulations. There are various types of operators in Dart, and we will review them now. There's the arithmetic operator that tells Dart to perform the typical math operations, addition, subtraction, etc. There's the postfix increment or decrement operator that tells Dart to add or subtract from a value. It looks like this: plus plus value, value plus plus, or minus minus value, that type of thing. There's equality, so we compare two variables to each other. We can do that with the double equal sign, the not equal, the greater than, the less than or equal to. The type test used for checking types at runtime. A is int, B is not, string, that type of thing. The assignment operator to assign only if the assigned to variable is null. It looks like this. The compound assignment combines an operator with assignment. So instead of A equals A plus B, the shortcut is A plus equals B. The logical operator: combine or invert Boolean expressions using logical operators like or and. We'll run through several examples of operators in action. We'll look at the postfix example first. So here we have in our main function 4 variables defined, A, B, C, and D. So A equals 0, then B equals plus plus A. So we're going to increment A before B gets its value. So then we print A, we print B, and both of them wind up being 1. Now here's the difference. We're going to increment D after C gets its value. So D equals 0, C equals D plus plus. Then we print D, we print C. What happens here? D is 1, but C is still 0. The difference here is key. See that C is 0 instead of 1 in this example because the increment happens after C gets its value. It's very important to recognize the difference. All right, now we'll take a look at the type test operator. So this tells us if the data type is correctly stated in our expression. So once again, we have var A equals 1, var B equals hello in our main function. We print A is int. That's how we use the type test. Is A in int? You can think of it that way. The return value is true. Is B in string? B is string. B is hello, so that better come back true, and it does. Now we do a negation. B is not int. That should also come back true because B is indeed not int, it's a string. Okay, for this third example, we dive into the assignment operator. This is something that was a little different for me coming from Python and other programming languages, but it's pretty easy to understand. We have var foo here. Notice that it's null because we don't have it assigned to anything. Now we use the assignment operator in line 119. Foo question mark equals 7. So since it has not been previously assigned, the value that gets printed out in line 20 when we do print foo is 7, what we assigned. By contrast, starting on line 122, var foo1 equals 10, so we have assigned a value to it. That being the case, it will take that value over what we assign in line 123 when we print out foo1. That's the difference. For the second example, foo1 is 10. Okay, the compound assignment operator. This, every single programming language that I've learned has. So this is something good to keep in mind. We have var num1 equals 0. Then we have num1 plus equals 1. This is equivalent to num1 equals num1 plus 1. And you can do this with subtraction, multiplication, etc. It's a shorthand to increase the value of your variable by 1 in this particular case. We can do num1 plus equals 2 or any other value. It doesn't matter. Conditional expressions. This is another construct that many programming languages have. In some, you may know it as ternary operators. Dart has two operators that let you concisely evaluate expressions that might otherwise require flow control or an if-else statement. We haven't gotten to that yet, but it's coming up. So here's the syntax. Condition, question mark, variable 1, colon, variable 2. If condition is true, it evaluates to expression 1 and returns its value. Otherwise, it evaluates and returns the value of expression 2. The second variety, this syntax is expression 1, question, question, expression 2. If expression 1 is non-null, it will return its value. Otherwise, it evaluates and returns the value of expression 2. That's much like what we just looked at with the assignment operator, isn't it? All right, time to look at an example of the conditional expression. In our main function, we have var foo equals hi, var bar equals hello. So we set bool f to false. Then we have another variable, result, where we use our conditional expression. F, which is false, question mark foo, colon, bar. So when we print the results print out to be hello. And here's why. Since f is false, bar's value is returned, which is hello, instead of foo's value, which would be hi. Okay, we're switching gears. Did you ever wonder how to get user input to be able to react and interact with your code? We're going to get to that right now. Dart has a mechanism to get user input at the command line. To do this, we must use a terminal to execute the code using the syntax dart and then our file name .dart. We use this command instead of the play button that we have been using in VS Code thus far. Also, we need an import statement. To make use of this functionality, we must first import the Dart.io library, just like I have here on 148, line 148. So let's check out the code. In our main function, we use a standard out.writeLine, which outputs a line of text. Then in line 152, we have a variable set user input to standard in readLine sync, which is a method. And then once we get that information, we want to do the standard out WriteLine again. This time, we're going to take our variable using string interpolation. Remember that? With the $ here, we're going to output that and we're going to see what we printed. So what happens here? You see down in the bottom in the terminal, I execute this code by issuing dart main.dart right here. Then they're prompted, type your favorite color. And I spelled favorite wrong. You like that? Good. I put in orange, which is my favorite color. Most of the time, I actually have 2. And then I output your favorite color is the value of the variable user input that I just got from the user, orange, and that's what gets printed out. Pretty simple. If you go up to dart.dev and look at some of the code examples, you will see that they love to use the assert statement. So let's dig in. We can use an assert statement in our development process to ensure coding assumptions are correct. So it's a way to test. To get our assert statements to run from the command line, you must do the following. Instead of just dart and then the name of the file .dart, it has to be dart --enable -asserts and then the name of the file. So here we have a variable num1 equals 100. And then we have assert num1 is not null. If the results of the assert statement resolve to true, our code simply continues on. If it resolves to false, an error is thrown. So if we see num2 equals null, our assert says num2 does not equal null, and that throws an error. So if your assert statement resolves to true, code will continue on. If not, an error is thrown. This seems like as good a time as any to talk about some important Dart concepts that you'll want to keep under your belt. Objects. Everything assigned to a variable is an object. Every object is an instance of a class, and all objects inherent from the object class. Functions. Dart supports top-level functions such as the void main that we've been using throughout the whole series so far. Dart also supports functions inside of classes and nested functions, which are functions inside of other functions. Variables. Dart supports top-level variables, variables in classes like static or instant variables. Instance variables, or ones associated with classes, are sometimes known as fields or properties. We'll get more to that when we get to object-oriented programming. Variables can start with either a letter or an underscore, but nothing else. Expressions and statements. Expressions have runtime values, like our conditional statement that I have here. Statements don't have runtime variables, such as the assert statement that I have here. Instead, no values for the if statement, for loop, or switch statement. They do things. A statement can contain one or more expressions. An example is an if statement can contain an expression. An expression, however, can't directly contain a statement. Again, you might not be able to digest all this right now, but keep this handy. Warning and errors. Things that Dart can report are warnings and errors. Warnings indicate a potential problem, but the code will continue on. Errors come in two types, runtime and compile. For the runtime, an exception is raised and code continues on. For a compile, it's the type of error that prevents code from executing. Again, keep these under your hat. Refer to them and you'll find it's helpful to you. Some additional important concepts. Slide 2, data privacy and concurrency. Dart supports public and private accessibility of a given declaration or object. A declaration is private if its name is private. Otherwise, it's public. In Dart, the name of the variable is private if it starts with an underscore, such as I show here in the underscore I'm private variable. This means private declarations may only be accessed within the library in which they are declared. Concurrency. Dart code is single-threaded. A thread is a single sequential flow of control within a program. Single-threaded means one command is processed at a time. Instead of threads, all Dart code runs inside of isolates. Each isolate has its own memory heap, ensuring that no isolate's state is accessible from any other isolate. All right, and we're switching gears yet another time. We're diving into the wonderful world of flow control. There is no way you can avoid this in any programming language that I've ever heard of, that I've ever used. Flow control statements in computer programs do just that. They control the way your program flows or executes. They are based on conditions. For example, if this, then do that. Else, do something else. There are several types of flow control constructs. Here, we're going to cover the if-else statement. So look at our code here. Once again, we have our main function as is required in Dart, and we have var age equals 21. Then we have our first flow control statement. If age is greater or equal to 21, print legal age. Else, meaning if it's not that, print, sorry, you're not legal. So being that our age is 21, it takes what we call the first branch, this branch right here, the if branch. Think of if statements like a switch. You can only go down one branch or one path, we call it a branch, at a time. So once it's satisfied, once the condition is satisfied, or the test if you like, it'll take that branch. It'll print out, it'll execute rather, whatever's in the body of that branch. So here, age, that condition is met. Age is greater or equal to 21, in this case equal, so it executes what's in its body inside the curly brackets, so it prints legal age. If it was not true, if that test came back to false, it would have no other choice. We only have two branches. It would print sorry, not legal. That's how this works. Still on the if statement, now we're going to deal with the else if clause. Notice here in the body of our code, we've added the else if clause in the middle. Now we have a choice of 3 different branches with which to take. We can only choose one. The code will only choose one still, whichever one first satisfies the test, but it still will only choose one. So notice the syntax here. Different programming languages do this differently. Else if, 2 separate words, else if. Python has the elif. You can have as many else ifs in your if statement as you like. So what is this doing? Var profession equals coder. So if profession equals musician, print plays tunes all day. Else if profession equals coder, now you see right here, our condition will be satisfied, our test will be satisfied. Print learns things all day. Else, print still trying to figure that out. And of course, because profession does equal coder, that's what it's set to in our profession variable, the value is coder, it will take the else if branch. And once it does, no need to go any further to the else branch. It prints it out and it will go on to the block of code immediately following our if statement. Now there is none here, so the code just ends. We are still on our journey of learning about flow control, but we're changing to a different type. Now we're examining the for loop. A for loop is a type of flow control statement which allows you to execute repeatedly. This is known as iterating. A for loop has two parts. There is a header specifying the iteration and a body which is executed once per iteration, so once per loop. The for statement in Dart has three forms. There is the traditional for loop and two forms of the for in statement. There's a synchronous variety and an asynchronous variety. Now, so far, all we've written is synchronous code. We will get to asynchronous in a later module. So our traditional for loop, we see the header, the for keyword, and then in parentheses, var I equals 0, then a semicolon, while I is less than 10, semicolon, I plus plus, which is an increment, right? We learned about that before. Then what do I do in the body? One thing, I print out I. So as you may guess, I is set to 0, so we know the very first time that will print 0 as long as the test is satisfied. I must be less than 10, and it is. Then after that, it will increment I. So we go for another round. The next time we iterate through the for loop, it's going to print 1. It always is going to check our tests. I is less than 10 if it's 1. Yes, it is. Print it out. Then we go for a third time. Now it increments. Now it's 2. Is I less than 10? If it's 2, it is. It prints that out. And so it goes until it gets to the very last time it checks it, right? We would be at 9, and then it would increment. It would increment to 10. Is I less than 10? No, it is not. So it stops its iteration. Now, on the right-hand side, we have the for in Dart loop. So I have here something called a list. It's known as a collection. Some programming languages might call it an array. The variable name we give it is colors. And we have 4 elements, red, blue, green, and purple. Sorry to spring this on you, but it was important to be able to show you the for in variety. So same type of thing. Var element, we can call this anything, E, whatever you want to call this, it doesn't matter. I decided to call it element. Var element in colors, which is our list, print element. So this doesn't have any kind of a test per se. It simply iterates until there are no more elements in our list. So you see the output here in order, red, blue, green, and purple, as you would expect. Okay, our journey with flow control continues, and now we're talking about while loops. A while loop is similar to a for loop, except that the code here is executed repeatedly based on a given Boolean condition. It can either be true or false. It's sometimes thought of as a repeating if statement. A while loop evaluates the condition before the loop executes. So here in the body of main, we have var x equals 0. While x is less than 5, print hello, then increment x. So this will be true for 5 iterations. Then x will be equal to 0, thereby making it false, and it will stop being true and will stop iterating. Okay, and another variety of the while loop is the do-while loop. A do-while loop evaluates the condition after the loop executes. So notice here in the body of main, we'll print out our text 5 times like we did before. Can you see why that is? Even though I'm saying that it evaluates the condition after the loop executes. Why don't you pause the video here and see if you can figure that out. Okay, did you figure it out? The answer is because it prints the last time when x equals 5 before the Boolean condition of x is less than 5 is evaluated. Then it recognizes that x is 5 and execution stops. All right, we're going to look at breaks as they relate to while loops. We have two different varieties here. Now we're using an if statement inside of a while loop. So we're using two different types of flow control. This is very typical. So way number one, our test is x less than 4? So we start out x equals 2. Is x less than 4? If x equals 4, break. It doesn't, so it prints still going. Then it increments. Now it's 3. Is x less than 4? It is. Then we test it inside the if loop. Does x equal 4? No. So it prints, still going. Then it increments. Now it is 4. Is x less than 4? No. It breaks. On the right-hand side, now we use the true variety. Instead of the test being x less than 4, is it true? So again, var x equals 2. It's true. If x equals 4, break. It's not. Still going, increment. Now what are we? 3. While true, if x equals 4, break. It doesn't. It doesn't equal that. So still going, we increment. Now we are 4. While true, it still goes. If x equals 4, it is 4. All right, so we break. It doesn't print, still going again. I sort of think of the continue keyword as a cousin to the break statement, whereas the break enables us to jump out. Continue allows us to skip the existing iteration and continue on. So here we have a for loop, and inside of the for loop, an if statement. And we're back to using our for in variety. So we have our list called colors with our 4 elements, red, blue, green, and purple. So we start for var element in colors. If element equals blue, continue. Well, it's not going to skip that one because the first time around it equals red. So it prints the element, it's red. The next time it does equal blue, right? If element equals blue, it does. It skips it. It continues on, and it goes around until I'm done with the list. So it prints out green and purple, and then it ends. That's how continue works. Okay, we're down to our last slide. Sad. We're still in flow control, and we're dealing with the switch and case statement, or the switch statement, or the case statement. Switch statements in Dart compare integer, string, or compile time constants using the comparison operator. The compared object must all be instances of the same class. Switch statements in Darts are intended for limited circumstances. Each non-empty case clause ends with a break statement as a rule. Other valid ways to end a non-empty case clause are a continue, a throw, or a return statement. We always use a default clause to execute code when no case clause matches. So this operates like a multi-pole switch having multiple settings. Like if statements, it stops at the very first one that satisfies its test. So in the body of main, we have command equals evening. So we have switch command, case is morning. Is it morning? No, it's evening. So it doesn't satisfy it. So we go on to the next. Afternoon doesn't satisfy it. It's evening. Now we get to the third. Case is evening. Print good evening. Then it breaks. We're done. Just that simple. It never has to get to the default because one of the cases did satisfy the test. My fine friends, thank you for making it all the way to the end. I hope you found this valuable. If you did, do a couple of things. Subscribe to the page, give me a like, leave a comment, and share this with somebody who might need it. We're trying to start a revolution here.